In this video, we're going to take a look at making predictions based on what we're a line of best fit. So a trend line or a line of best fit is known as a line that represents the trend of data. So we saw in the last video about data trends, whether they're positive, negative, strong, or weak. So when we're creating a line of best fit, we want to think about if we took all of our points and smooshed them together, what would be the best approximation of all of those points? And we usually have about the same number of points above and below our line of best fit. And something to note is that our line of best fit does not have to go through the origin. So here's my origin, 0, 0, does not have to go through the origin, just like most lines that we graph don't go through the origin. So for this, we're going to want to use the trend line to predict some data points at other locations on the graph where we might not have exact points. So in order to do this, we're going to have to create our scatter plots. So just like before, we're going to think about these as points, right? And we already know what was on our x-axis and y-axis. So items are on our x-axis, cost on our y-axis, and we're going to plot these just like points. So the point 3, 16 is going to be approximately there. So I'd like you to take a moment and do all 3 of the graphs on this paper. Excuse me, all 2, both of them. Once we have all of our data plotted, we can approximate our line of best fit. I find the easiest way to do this is to draw an oval around the points as tight as you can get it, and then identify the middle parts of the ends of your oval and go ahead and draw a line through that. And that makes a pretty good line of best fit approximation. Now we're going to use that line of best fit that we just created to approximate some values. So this asks us, predict the cost of 16 items. So what we're going to do is we're going to go to 16 items. We're going to go up to our line of best fit, and then we're going to go over from that point to our y-axis, which has the cost. And we're going to say, oh, well, that's about maybe $88. And because we're talking about something in context, make sure to use units. So next we're going to predict, what about 20 items? So for this, I might need to extend my line of best fit. If I go to 20 items and I go up to my line, I'm almost going off my graph here, but I can still approximate it. This would be about 100 and about 110, maybe about $110. Okay. If it costs $90, predict the number of items. So this time we're going to be going on to our y-axis. And we're going to say, okay, well, what if we were at $90? We're going to then go over to our line and back down to approximate how many items that would be. And that would be about 17 items. So we can use this in both directions to approximate some information. So let's do the same for this one. We'll create our line of best fit. So we're going to draw a nice oval around these points and try to go through the middle of that to create a good line of best fit. So there is a technically correct way to create a line of best fit, but right now we're just approximating one. So eyeballing it, we could say. So predict the time to travel 5 miles. So 5 miles would be right here in between 0 and 10. And that wouldn't take much time at all. That might just take 10. And we're working with minutes, so our time is minutes here. That might just take 10 minutes. Predict the time it would take to travel 65 miles. Okay, well, 65 miles is going to be about there. We're going to go up to our line of best fit and then go to that matching location on time. That looks about 110 minutes to me. Right? We all might have slightly different answers here, but we should be within a ballpark of each other, right? Kind of close together. So then if it takes 160 minutes to travel, how many miles did we travel? All right, so here's 160 minutes. We're going to do the same thing over to our line of best fit and then down to look at how far we traveled. And that would be 90 miles.